Okay, so voltage here, 2 volts, LED. Current here, IC. This one, VCE, 0. Why is it 0? I'm forcing this circuit into what's called hard saturation. This is hard saturation. What does hard saturation mean? I've got such a large gain that that gain is going to cause a theoretical current value that is so high that my transistor is going to go into saturation and just stay there. And when it stays there, it basically means that the voltage across that transistor is going to stay close to 0 and stay in that value. So there's 0. Now, with hard saturation, okay, let's now calculate IC actual. Calculated is this much. This is calculated. Okay, calculated was 339 milliamps. Actual is what? Look at a circuit like this. We've done this kind of a circuit 100 times. I've got VCC, 10 volts is it? This is 2 volts. So what is the, and this is 330 ohms. So can I calculate IC in this circuit? Is it VCC minus VF at LED divided by RC? So is it 10 minus 2 divided by 330? How much? 24 milliamps. Okay, so if I was to build a circuit like this, which I'm going to, in the lab this week, one of the parts is to build a Darlington circuit. I'm going to measure the current in this circuit, okay? And what am I going to read? I'm not going to read 300 milliamps. I'm going to read about 24 milliamps. So the calculated is an absurd number, okay? It's just a value which is based on that big gain, but the actual value is 24 million. So let's see what the note at the bottom of the page says. In other words, the actual current flowing in the saturated transistor Q2 is much smaller than the calculated current. So the calculated current in my circuit is 300 milliamps. The actual current is 24 milliamps. Okay. So that's a Darlington pair. And we're going to build this circuit in the lab. We're going to hook up exactly this circuit with an LED. Watch the LED turn on. We'll measure the current. We can just take the voltage across RC and divide it by 330. That will also tell us the current. We'll measure the current at Q2, see if it is close to 0, okay, because of this business of hard saturation. So let's read the note, the 4th line from the bottom. Note, this is a very large IC in Q2, which is this value here. It causes Q2 to go into hard saturation, okay? This business of a large current means that the transistor goes into a hard saturation, which basically means that the voltage across the transistor is going to be close to 0. Because we know that when I push the current to its maximum value, the voltage is going to be close to 0. Okay? So that's our notes number 11B.